Do you know what a ball in flight, the arc of a water fountain, and the shape of a satellite dish all have in common? The quadratic function. Today, I'll show you how this curved equation can describe movement, trajectories, and much more. The quadratic function, also known as the parabola equation, looks like this. Y equals ax² plus bx plus c. The value of the letter a is essential. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward. The larger the absolute value of a, the narrower the curve. If a is smaller, the parabola becomes wider. This isn't just a matter of aesthetics. The direction and shape of the curve can determine whether an object lands safely or misses its target. In engineering, for example, a precise parabola can guide the path of a beam, the reflection of sound, or even how a signal bounces in a satellite dish. That curve is more than math, it's function in motion. But what about B and C? Both also affect the shape of the parabola. The value C tells us the exact point where the parabola crosses the y-axis. The value B affects how the curve tilts, shifting it to the left or right. When you graph a quadratic function, you're not just drawing a line, you're setting up a visual story. The vertex becomes the climax. The axis of symmetry divides the journey in two, and every point along the curve represents a real-world possibility: time, distance, velocity, height. Suddenly, a curve on paper becomes a flight path, a light beam, or the rise and fall of a jump. Let's recap. A decides whether the parabola opens up or down. B affects the tilt and position. C is the point where the curve touches the y-axis. Together, these values define the shape and position of the curve. But the quadratic function is not just theory, it's all around you. Every time you throw a ball into the air, its path follows a parabolic trajectory. You'll also find it in planetary orbits, water fountains, architectural structures, and in technology, like satellite dishes. From the flight of a rocket to the suspended cables of a bridge, whenever you see a perfect arc in the air, remember, behind it lies the mathematical magic of the parabola. Because in the end, the quadratic function doesn't just explain how we move, it shows us how to reach new heights.